We all know about the atom as it is known today, but where did the idea of the structure of atom come from? How can we have a picture of something that's so small that we can't even see it? Well, it all started with Democritus. He was an ancient Greek philosopher who was the first to propose that matter is comprised of fundamental indivisible particles which he called atomos. Though this marks the first time matter was viewed in this way, it was more of a philosophy than real science, and no supporting evidence was gathered for a long time until John Dalton came along and provided the first empirical evidence that atom exists. He proposed that all matter is made up of very tiny particles called the atoms. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kinds of atoms are constant in a given compound. This was the first solid evidence that atoms exist. However, it was soon discovered that Dalton's atoms were not the fundamental indivisible unit of matter that Democritus envisioned. J.J. Thomson showed that the atom must consist of smaller particles when he discovered the electrons. In his cathode ray experiment, particles ejected from a neutral material were shown to have a negative electrical charge. Since they were all attracted to a positively charged metal plate, this means atoms must have within them positively charged and negatively charged particles. But he did not know how they were distributed, so he proposed his plum pudding model. He said that the electrons in a sphere of positive charge were like dry fruits in a spherical Christmas pudding. Thomson won the Nobel Prize in 1906 for his electron discovery, but his model of the atom didn't stick around long. This was because he happened to have some pretty smart students, including certain Ernst Rutherford, who is known as the father of nuclear physics. While studying the effects of X-rays on gases, Rutherford decided to investigate atoms more closely by shooting small positively charged alpha particles at a sheet of gold foil. Under Thomson's model, the atom's thinly dispersed positive charge would not be enough to deflect the particles in any one place. But while most of the particles did pass through, some bounced right back. Rutherford concluded that atoms consisted largely of empty space with just a few electrons, while most of the mass was concentrated in the center, which he termed the nucleus. The alpha particles passed through the gaps but bounced back from the dense, positively charged nucleus. But the atomic theory wasn't complete just yet. Niels Bohr, another student of J.J. Thomson, expanded on Rutherford's nuclear model. He stipulated that electrons orbit the nucleus at fixed energies and distances, able to jump from one level to another, but not to exist in the space between. Bohr's planetary model took the center stage and is widely accepted. Even though our understanding of atoms keeps changing, the basic fact of the atom remains the same. That is, it is the smallest fundamental unit of matter, and Democritus was right all along.